In the realm of scientific innovation, Naman Bolak's work stands as a testament to the transformative power of genetics and molecular biology. His groundbreaking research revolutionized agriculture and saved millions from starvation.
Naman Bolak born in March 25, 1940 in Cresco, Iowa. He began his journey at a small farm. This early experience led him to pursue PhD in plant pathology and genetics at the University of Minnesota.
In 1944, Bolak joined the Cooperative Wheat Research and Production Program in Mexico, funded by the Rockefeller Foundation. Mexico faced severe wheat shortages, and Bolak's mission was to develop high-yielding, disease-resistant wheat varieties.
Bolak's groundbreaking experiments was deeply rooted in genetic and molecular biology. He employed traditional crossbreeding technique alongside cutting-edge genetic principles to create robust wheat strains.
One of Bolak's case strategy was shuttle breeding. He planted wheat in two different climates each year, the highland of central Mexico and the lowland near the coast. This accelerated the breeding process and enhanced genetic diversity.
You might not know this, but every day you reap the benefits of plant breeding. In fact, much of what you eat could not exist without it. Plant breeding started many thousands of years ago when people first domesticated wild plants. By selecting the best plants and breeding them over time, ancient farmers cultivated crops that were ever tastier, more nutritious, and more resilient. As scientists like Gregor Mendel began to discover how plant characteristics are passed from one generation to the next, they laid the foundation for our modern understanding of plant genetics. As the years went by, scientists' understanding of agriculture continued to progress. In the 20th century, we made incredible breakthroughs in understanding the mechanics of genetics, DNA, the genetic code, and how to read whole genomes. Each advance increased the efficiency of breeding better crops. Today, our understanding of how to harness plant breeding continues to progress, but we also face new challenges every day, like the global spread of plant diseases and pests, dwindling natural resources, climate change, and skyrocketing global population growth. Helping farmers keep pace with these challenges in a safe and sustainable way continues to be the goal of plant breeders. Thanks to our understanding of genetics, we now know how plant breeding works at the molecular level. When scientists combine genes from two related plants, their offspring have a mix of characteristics from both parents. But plant scientists have to selectively breed plants for many generations to single out one desired characteristic, a process that can take years. Now, innovative gene editing techniques allow plant scientists to use DNA from the plant's family to directly add, delete, or replace specific genetic information using its own biological processes. Just like traditional plant breeding, but with greater precision and efficiency that we've come to expect in modern times. Throughout history, consumer and farmer needs have been answered with science. What could the future hold? More sustainable food production, better tasting and more nutritious produce, increased protection of plants from drought and diseases, adapting the basic principles that have been used for generations.
Shuttle breeding allowed Bolak to expose wheat to various environmental pressures, speeding up natural selection. This method helped him identify and select for desirable genetic traits such as disease resistance and drought tolerance.
One of Bolak's most significant genetic innovation was the development of semi-dwarf wheat. By incorporating dwarfing genes from Japanese wheat varieties, Bolak engineered shorter plants that could support larger grain head without logging. This semi-dwarf Variety were a genetic breakthrough. Their shorter stature made them less prone to damage from wind and wind, and they responded well to fertilizer, which dramatically increased their yield.
Bullock's genetic improvement didn't stop there. He also focused on breeding with resistance to stem rust, a devastating fungal disease. By understanding the genetic basis of rust resistance, he was able to incorporate resistant genes into new varieties.
Bullock worked on rust resistance involved detailed genetic analysis and selection. He identified specific genes that infect resistant and used traditional combining to integrate these genes into high-yielding wheat stands.
Bullock's methods have wide-ranging applications beyond wheat. His genetic techniques have been adapted to other crops, improving resistance to diseases and pests, and increasing yields in rice, maize, and other staple foods.
This method has also influenced the development of genetically modified organism GMOs, allowing scientists to directly modify crop genomes for desirable traits, further enhancing agriculture productivity.
The advantage of Bullock's genetic methods are clear: increased yield, enhanced disease resistance, and greater food security. These innovations have helped them alleviate hunger and improve livelihood around the world.
However, they also disadvantage. The reliance of high-yield varieties can lead to reduced genetic diversity, making crops more vulnerable to new diseases. Additionally, the heavy use of fertilizers and pesticides can have environmental and health impact.
Balancing disadvantage and disadvantage is crucial for sustainable agriculture. Ongoing research seeks to mitigate the negative effect while maximizing the benefit. Numerous case study and articles have documented the success of Bullock method. One notable example in the widespread adoption of rust-resistant wheat in South Asia, which significantly reduced crop losses and boosted food security.
Published research has also explored the genetic mechanisms underlying disease resistance and yield improvement, providing a valuable analytic for future genetic and molecular biology research.
Bullock work continue to inspire advances in genetic engineering and molecular biology. Techniques such as keeper gene editing and genome sequencing have been informed by his pioneering method, pushing the boundaries of what is possible in crop improvement.
As Bullock once said, the first essential component of social justice is adequate food for all mankind. His groundbreaking work in genetics and molecular biology exemplifies the power of science to change the world.